Hello all, I'm Bharathi Ram, Engineering Manager for the Reliability Engineering team at Pluto TV. I'm managing a team of problem solvers to implement observability and SRE best practices as Pluto TV. Um, I'm here today to share our journey of how we deployed OpenTelemetry organizationally from a proof of concept to a production at scale. How many of you know Pluto TV here? Raise your hands up. Cool. All right. So a brief intro about Pluto TV. So Pluto TV is one of the leading free streaming television service in America. And we have hundreds of channels. We have our apps available in more than 30 plus device platforms. We stream both linear and video on demand content. And we have close to 70 million monthly active users right now at this point. And it's free, it's no limits, no trial. It's Pluto TV for you. With Pluto, we are generating close to more than $1 billion in revenue, in annual revenue, and we have our content available in 30 plus countries. We have thousands plus global channels, and we have more than unique 50,000 of movies and TV titles. So we are one of the top 5 streaming service in terms of monthly active users. As you see here, close to 68 million monthly active users. In terms of tech, so we have team members across Pluto working on 14 different time zones, and we are generating close to 1 gigabyte per second of log volume, and we have our services in combination have to handle requests more than 40 million requests per minute. So in general, observability is hard for a scale this big. It's even more harder when we have to deal with multiple observability tools. We need to switch between multiple tools. When I joined Pluto TV 2 years ago, we were using multiple observability tools to collect the telemetry data in terms of logs, traces, and metrics. And during an incident, we lose a lot of our time in switching between these tools rather than solving the actual incident. So, and all of our energy went in context switching between the tools than resolving an actual problem. So, how do you get an organization buy-in for a single observability system? So there are some challenges on the way before we even go into a single observability system and how a single observability system would look like. So these are some of the challenges. I grouped it by 3 categories here. Sorry. The first one is the existing observability tools. What do you want to do with the existing observability tools? We already have multiple tools, as I mentioned, collecting the telemetry data. What are we going to do with those tools? We have multiple data formats that we were supporting right now to expose this telemetry data. So, and currently we have like vendor specific instrumentation inside the code that already sending the data to the corresponding vendors. So those are some of the existing challenges that we had before even starting the conversation. And the next one is the consolidation challenges. Here, if we think about consolidating, we need to re-instrument more than 80 microservices. And we have to deprecate the old instrumentation. We have to migrate the data pipelines from the old vendors to the new vendors. And we need to compare the old systems to the new systems. And we need to make sure that both of them are giving us the same data. And there is a historical data retention problem as well, like where certain services need to retain some of the data so that they can compare the data historically for them. So the last one is the budget and vendor selection. So the new observability vendor landscape is too vast, as I showed in the previous diagram there. And which vendor will fit our specific needs? And why do we need to even spend money when there are open source solutions that are already available? And and how to justify the value of a single observability system when we don't have real data to show how it would look like. So, so those are some of the challenges to even start with. So what we clearly understood back then was that we cannot even have a conversation with our leadership team without finding a solutions for the first two challenges. Because like we don't have enough data to either to show the leadership team how it would look like, so it will create a lose-lose situation there. So with that challenges, where do we begin? So OpenTelemetry instrumentation was started as a side project. So back like 2 years ago, so we were at 20 million monthly active users back in 2020. And with OpenTelemetry, I pitched the idea to my manager in my one-on-one about, hey, there is this new tool that can consolidate the data for us and put a simple example of how it would look in action, so it just came out of a one-on-one conversation. My manager insisted me to build a POC so that we can show to a bigger group. So in Pluto TV, we have a strong innovation culture. Anyone, irrespective of their role, can present an idea to a group, to an architecture guild, which consists of a group of architects and tech leads. And if we get enough traction for that idea, then we can go ahead and build a POC on organization level. So we got the approval for building an OpenTelemetry instrumentation to implement OpenTelemetry on the organization level as a POC. So first thing first that we started to do was, instead of focusing on the destinations of the vendors of where we want to go, we started focusing on the source of the data, which is how we want to expose the data. So we started standardizing the formats that how we want to expose this data from the service. So, and we narrowed down the formats that we want to support to the external world. So these are some of the services. These are some of the formats that we narrowed down on. And we also made sure that all of these formats are open source. There is no vendor-specific formats that we want to use, since we don't even know at that point like which vendor we are going to go. So the next one is transport. So the first part is the formats and how we want to send this data to the aggregator or a collector. And so there are a few options there as well, and we standardized those formats as well to narrow down. So, and we built the instrumentation libraries on top of the OpenTelemetry instrumentation library to support these formats, which helped us to instrument the services quickly on how we can expose this data and transport this data to. OpenTelemetry collector. So once we finish the instrumentation part, the next one is how we want to collect this data to. So OpenTelemetry collector has three main components, like receivers, processors, and exporters. So receivers are basically how you want to receive the data from services to the OpenTelemetry collector. So it could be a Stats3 receiver, it could be a Prometheus receiver, it could be a Zipkin receiver. So this is about how you want to get the data into the OpenTelemetry collector. And once you receive this data into the OpenTelemetry collector, then you want to process the data in terms of remapping, relabeling, adding span tags, removing span tags, make some security constraints on top of the data that you're collecting. So that you can do in the processor. So there are a lot of processes that are available, like, for example, adding Kubernetes metadata processor. And the last part is the explorer, which is choosing your destination, where you want to go. Could be a S3 bucket, could be a Datadog Explorer, or could be a Splunk or SignalFX Explorer. So those are some of the destinations that you can choose where you want to go to. So with OpenTelemetry instrumentation and OpenTelemetry collector, we are at a place where we can consolidate the data irrespective of which vendor we want to go in at this point. So at this point, we want to validate our system end to end. So we already have Elasticsearch running over our clusters. So we started leveraging the open source observability system in Elasticsearch to start sending this data and start analyzing the data. So for this demonstration purposes, I choose traces as an example, but you can imagine how it would work for metrics and logs, because metrics and logs are much more straightforward than traces. So here we have, and also we started with a very simple architecture without any service mesh or anything in the upfront. So we have a request coming in to a service LO, and service LO is a Go service, which is got instrumented using our the instrumentation library. And so the main functionalities of the library in terms of tracing, it needs to initiate, if there is no trace ID exists before, it needs to initiate the trace. This, which is, it needs to generate the unique trace ID and a unique span ID. Once it generates the unique span ID and unique trace ID, then the next functionality that we need to do is do the parent-child span mapping, which is, so for example, the ping service here needs to know that LO service is the parent span ID. So the library instrumentation need to make sure that it needs to propagate those IDs to the downstream services. Pretty much similar as you see here, the XB3 trace ID remains the same throughout this flow. The only thing that's constantly changing was the parent span ID and the span ID. And the library needs to make sure that this propagation functionality is taken care of. And there are multiple different instrumentation that you can go with. We used HTTP, so we have a HTTP instrumentation, but there is a gRPC instrumentation available, so you can interject any of the communication between these services and add these headers or metadata on top of it. Now, another functionality of the library is to, we collected this data and we need to send a data to a destination. And that's OpenTelemetry collector. So the OpenTelemetry library need to make sure that it's sent to a destination. And in this case, it's OpenTelemetry collector, and through the receivers that we already spoke about. And from there, once you get the data in the OpenTelemetry collector, then we can say which destination we want to export it to. That could be OpenSearch or say Elasticsearch. I got my animation reversed here. So we send it to the data Elasticsearch initially first. And I don't know whether you guys remember last year, we got in this transition between the Elasticsearch and OpenSearch problem, because Elasticsearch after 7.10 version came out and said, we are not going to be open source anymore. So, I think the open source community created a fork out of the 7.10 version and created OpenSearch. That gave us an opportunity for us to put our theory to test. Like, perfect. We were sending it to Elasticsearch, and we don't need to touch any of the services. Let's experiment with adding another exporter, which is the OpenSearch, and there you go. So we got the same data in both Elasticsearch and OpenSearch. Now, architecturally, we added a Istio service mesh. This is more for service communication layer. So we started leveraging Istio, which is a service mesh. So a service mesh, like in simple terms, is used to control the communication between the microservices. So you can add policies and whatnot to the service mesh. So the way it works is, so every app container that's running in a pod will have a sidecar proxy envoy. And the envoy can take care of all the ingress and the egress traffic that is coming into the pod. So it controls the TCO, the termination for mutual TLS, and the egress and ingress traffic, and monitoring the traffic in and out of the app container. So as you see here, it's a expansion of the previous architecture. So we added a Istio. So when a request comes into a cluster, it hits the ingress gateway first, which is pretty much a network load balancer behind, and then there is an envoy proxy running behind. And here, as I've mentioned before, the OpenTelemetry library was generating all this for us. So with Envoy, it automatically generates the XB3 trace ID. The initiating trace part is already handled by Envoy. So the library doesn't need to do anything, and the Envoy will take care of initiating the trace for you. And once you initiate a trace, we have a service, we have a request coming into a service. It hits the Envoy sidecar proxy first, which takes care of the parent side span mapping as well. So the amount of work the library needs to do got reduced a lot. Same thing, same. Oh, it goes to the only difference is, it goes to the Envoy proxy first. It will take care of the child span mapping and generating the span ID and everything for you. The only job for the library at that point is to make sure that it propagates all the context headers along with the outgoing request. That's all it is. So it doesn't need to do any child span mapping or sending the data. It's another example. So here, the final one. So the another functionality that we spoke about, the library used to handle before, was sending the data to OpenTelemetry collector. Now, in Envoy, in Istio, you can set up a configuration on the mesh level. So you can choose the destination where you want to send the data to. So you can collect all the data in the OpenTelemetry collector from the Envoy. And from there, pretty much the same workflow exists, yeah. So that's how we send the data and started leveraging Envoy to take care of most of the work that library was doing previously. So one quick point, our pro tip here. So OpenTelemetry has a B3 propagation function that where you can propagate all the B3 headers to. Envoy specifically adds X request ID, which is a unique request ID for that whole trace. So we need to make sure that that X request ID get passed as well. So the way we found a workaround for that is we built a custom propagator that uses the OTel baggage under the hood to pass the X request ID, and we created a composite propagator which combines both the custom propagator that we built and the existing B3 propagator to send the data to the OpenTelemetry to propagate the headers. So now we are here. We already instrumented the services. We already collected the data, and we have it in a single place where we can start exploring and probably, like thinking about a vision of bringing everything into one single place. And that's where data correlation comes to play. So talking about logs and trace correlation. So to me, logs can tell like what is the problem. It's very non-contextual. It can only tell you like, okay, this is what happened, right? Like, so the traces can tell you where is the problem have happened. And when we combine these data together, then we're starting to see more context-rich logs in a given context of how it would work. So as you see here, so with every single trace, you have a span context. And you can start injecting the trace ID and span ID into the log contents. By that way, we can see the logs and traces are being connected together. So now we are at a point in our overstretched POC that where we can ready to face that third challenge of budget and vendor selection point. Because we have enough data to prove that, okay, how this could be valuable for us, how whatever the things that we have built can solve over some of the problems. And most importantly, the open source solutions, visualization is one of the key components when it comes to observability. And the open source solutions didn't justify or didn't didn't justify the the work that we put to build all this instrumentation and all these services, and visually it doesn't appeal to us of when we saw the data. So that's when we started exploring some of the vendors, paid vendors, to see if we can start looking at other options. And because of its open telemetry, it's much easier to do because it's all about adding one more explorer if you want to export to another destination. So this is how OpenTelemetry helped us. So OpenTelemetry helped us to compare multiple vendors. So we started sending the same data to multiple vendors, like um, in terms of like the paid vendors that we want to evaluate. And it also provided backward compatibility. I think this is more important because we need to make sure there is no disruption when we are doing this experiments with this data that we are collecting. So we are also sending the data to the old systems that we are already using, in addition to the new systems that we are trying to evaluate the product of. And this also helps us to assess vendors without any additional instrumentation. So we don't need to touch any of our services to change the destination or whatnot. Sorry, to change the destination or whatnot for the vendors. And it also helped us to evaluate the real data. So usually when we have to choose the observability, usually there'll be a demo services or demo data that we send, and we will see magically everything works. So this helped us to evaluate with real data. We started sending real production data to some of the services just to really evaluate, is this solving some of the problems that we are facing? And we got some good answers for it, and it really helped us a lot. And you can also route based on trace and span origin tags. So we can specifically route in the OpenTelemetry collector, hey, this set of services needs to go to this destination, this set of services go to different destinations. And that helps us to understand only, instrument only few of the services and then start sending them data for testing. And the last one, it helped us to get a Datadog and build a case for observability budget. Because since we have, this is going back to the third challenge I was talking about. Since we had a plan for the backward compatibility and resolved most of the first and second challenge, it gives us an opportunity for us to have this conversation with the leadership team about when we put the vendors side by side and the observability solution side by side, they're starting to see the value of what we might get out of this system like this, of having a single observability system in a one place, and how it can solve some of the problems that we have right now. And we ran into some scaling challenges. As you can see here, when we started this project, we were at 20 million monthly active users, and we were close to 68 million monthly active users now. So you can see how that would bring us like a lot of scaling pains there. So these are some of the solutions that we adapted to scale our architecture. So tail-based sampling. So with head-based sampling, one of the problem was the sampling decision was very early in the service flow. And it usually at random because we don't have a lot of information about what's that request is doing. So it's most of the time that sampling is without a lot of context. And the tail-based sampling, we can deploy the sampling decision. We can delay the sampling decision until we get to a point we collect all the span tags. So by that way, we can say, hey, the sample only the high latency traces, so I don't need to keep all the traces, right? Like, or sample only the 5xx and 4xx, so I don't need to sample the or don't sample all these traces, and sample only the info traces or whatnot. So that gives us an opportunity. And OpenTelemetry collector have a tail-based sample processor that we can use to, based on a set of policy, to control this data collection. The next one is load balancing the traces. So as I mentioned before, it's the existing architecture that we had before using the STO. So one of the things that you might have noticed is here, so ingress gateway is a high traffic service because every single request coming into the cluster comes through the ingress gateway. So that will have a high volume of traces. And let's assume that the service pink towards the end has a high volume of traces as well. So the number of traces that we want to collect for these services completely differs. So the scaling of how you want to scale the OpenTelemetry collector is differs as well. If you use a single OpenTelemetry collector, we use a single OpenTelemetry collector in the middle, then that's our only choice. So what we did was, so we started leveraging the load balancing explorer, where you can export it to multiple different OTel collectors as well. By that way, you can specify, hey, you know what, for gateway traces, create a set of OTel collectors and pipe all the traces into the OTel collector, and you can individually scale the OTel collector according to the gateway traces traffic. And let's say the service yellow and service orange has limited traffic, it's not a lot, then we don't need to have like that many pods running for that OTel collector. You can do that as well. And service pink is a high volume service, as I mentioned before, and you can completely scale it independently. So by this way, it gives us so much flexibility in terms of how we want to scale these systems. So these are some sample configurations we used. For load balancing, that's how you split the data between the OTel collectors. And we haven't touched on persistent. So persistent storage is more for if there is an outage in your destination, if there is a, if you're getting timeouts in the destination. During that point, you don't want to lose the data. With persistent storage, it creates a file storage for you so that you can store the data temporarily and retry after a certain point of time. So by that way, you don't lose any data during the transportation process to the destination. So this is a page to show the popularity of OpenTelemetry. OpenTelemetry, in terms of contributions, last year it was next to Kubernetes at this point, and it's widely growing. So where are we now? So we started with all these challenges. We crossed through the challenges. So this is what we used to be before. As I said, multiple tools. And this is where we are right now. So we have a single dashboard where you can see logs, traces, and metrics. Gives you a single source of truth. Same thing here. This is a log and a trace correlation. This is how it looks, and it uses the OpenTelemetry trace ID ingested into the logs, and that's how it's being connected. So you need more secret sauce. So these are some of the lessons that we learned from a technical perspective. Pay attention to the industry trend. So when we started working on this project, you can already see there are a lot of consolidations started to happen in terms of like some of the logging vendors started buying the metrics and the APM vendors, and then like the traditional APM vendors started supporting logs. So we can already see a single observability system is probably the new future. And also OpenTelemetry is going to play a big role in changing that, in creating that future. So you can see the trend already growing, and we identify that very early. And yeah, design data pipelines with backward compatibility in mind. Like this is important because we need to make sure there is no disruption to the existing services that is sending data to the current pipelines. And that will make it easier to adapt the new architecture or adapt the new systems in place by giving them a way out of for the existing systems, and also help them to compare what it would look like in a new system versus an old system. And standardize the data formats earlier, because this narrowing down the formats, as I mentioned before in my the previous slides, that helped us a lot in terms of how much work that we want to do to transport this data. So by doing that, we reduced a lot of workload in terms of how we want to organize this data, how we want to correlate the data together. So that reduced a lot of workload upfront. And build drop-in libraries. So build a drop-in library with a good README documentation of taking the library, drop it into the service. Any developer can just take it and drop it in their service, and they can immediately start open, like observability data. So that's a big important point, I guess, like for wider adoption in the organization. And build demo services to show the value of the libraries and value of the new observability system on how it would look like, so that the developers can follow the same thing along the lines, so that they can also compare and see and start maybe break the demo service to see why it's not working and learn from it. Next, continuously evolve the architecture as you scale. Because, for example, when we started, we didn't even know we had Istio, and we didn't even because that was not in our radar, and it slowly got added in. So we kind of evolved our architecture as we go and started leveraging some of the features for it. So these are some of the lessons that we learned from a management perspective. So identify the evangelists and the early adapters within the organization, so that finding the like-minded people and who want to solve the same problems as you, it's important, so that it creates a community together. We can have like a meetings, bi-weekly meetings, to make sure that they are happy with the results they are seeing, and they could be your evangelist as well. And clearly defining the value proposition before seeking approval. Particularly because, as I said, like doing this research for this long, to make sure that we tested it on this open source observability systems, and having this comparison, side-by-side comparison, it gives the leadership team an opportunity to see what we have built and what we can see in what we can build in the future, and what are the things that we can achieve in the future with the new observability system in place like that. So I think that's really important, I guess, like to make sure that before seeking the approval, create a case for value. Yeah, change is hard. So as with any system, people are used to a certain tools, and service teams and like the operations teams are used to a certain tools. So it's always harder to move away from an old system to a new system. So as part of that, anticipate difficult questions, like in terms of architecture, or in terms of like the support of the features that we needed. So be prepared for those questions, so that we can navigate those very earlier. And over-communicate the designs and the architecture and the rollout plans. I think this is important to have less friction when we want to implement the pipelines and everything, to make sure that the developers and the involving teams understand that, okay, this is not going to be disruptive. This is going to be much more of an addition to what I'm already seeing. So over-communicate the plans, show them the architecture, so that they understand, okay, so this makes me feel good to adapt this system, because it's not going to break the existing ones I have. And be relentless with the long-term goal in mind. We were doing this not because it was easy, we were doing this because it was hard. So, and that mindset helped us a lot in building a system like this. So be relentless about where you want to go, how you want to, which direction you want to go in terms of observability and reliability. And thank you for the opportunity, and hope some of the information I shared here helped you guys a lot. We are always looking for reliability engineers, so reach out to me in my LinkedIn if any of the problem that I discussed interest you. Finally, thank you for the Pluto TV leadership team for giving us an opportunity to build a good observability system. And finally, thank you for my 1-year-old for doing all the cooperation during the project. So thank you. Yeah. Any questions?
Thank you. That was fantastic. I learned a lot. I really appreciated all of the actionable takeaways. So we have time for a few questions. I will start with an easy one for you, which is how long was this journey from proof of concept to in production? Was this 2 years, year and a half?
2 years.
2 years. Okay.
2020 Q4. Yeah.
Okay. So your 1-year-old gets half of thanks.
Yeah.
Who's got questions? Yeah. All right. Start up right here.
So going back to your load balancing,
Yes.
With the latest release of the Datadog agent now,
Right.
ingesting the data itself,
right.
Can we skip that load balancing step with the Datadog agent?
So we haven't looked into it. Like I think I saw an update in the OTLP side. So I haven't looked into it yet for like how the Datadog agent will replace it. But so far I didn't think it was possible. So with the Datadog agent, like how we can load balance it that way. We can, because the only thing that the Datadog agent added was support the OTLP ingestion and not the load balancing the traces part. So
other questions? All right.
Hey, thank you. Good presentation.
Thank you.
Quick question on the log side.
Yes.
The OpenTelemetry doesn't have the log forward, right?
Right.
And now Datadog is coming up with new libraries.
Right.
So if Datadog serves as the entire platform for single telemetry system,
Sure. Yep.
how do you make a decision to go to hotel or just go with Datadog?
Yeah. It was. We are in a similar position as well. Like I think even though OpenTelemetry helped us in this transition, Datadog was supporting. So I think it's going to be case by case basis based on the companies. Like, do you want to be? Do you guys see yourself in Datadog? Or do you want to send data to S3 buckets? Like, for example, if we have a use case where we need to send data to S3 buckets, where we need to send to other destinations as well for some BI analysis and everything. So it's going to be used case by case basis on which direction you want to go and how much. I think the OpenTelemetry instrumentation is the key part, I guess. When it comes to even collection, like for logs, recently, they added a fluent forward receiver to the OpenTelemetry, and you can see I already see a lot of developments on the logging side for OpenTelemetry in the next few years. Yeah.
Time for one more question if there's one. Okay, great.
Hi, good presentation. Thank you.
you.
I have just one question. Like, you have said that as you have grown over 20 million monthly active users to 83. Have you seen those intermittent scales where there is a certain movie or a pay-per-view or something like that has opened up, like 10 million new connections have opened up? A scenario like that where how does your scale handles this kind of intermittent spikes of
So all of our services are running in Kubernetes clusters. So it's already have a HPA installed, horizontal pod autoscaler installed. So we can scale horizontally for some of those cases where there is a specific need, let's say, for like when there is a spike, like someone tweeted about a channel, some celebrity tweeted about a channel, we see a spike in the traffic, and that will be already taken care of. Yeah.
How does the tracing solution is able to catch up to that kind of, because let's say you're saying your average log volume was around 1 GB kind of thing. Let's say at a certain period of time it became like 10 GB. I'm just building up the numbers here. How do you handle that kind of scale on your? I am not worried about your application point of view, but from your tracing point of view, how do you handle that kind of scenarios?
As I mentioned, I think scaling the pods is the way that you scale the pods horizontally as much as you can, and then start supporting the trace. And one other thing was, like, we are also based on the tail-based sampling, we are controlling the amount of data that we want to ingest, and so we drop most of the data and convert some of the data from logs to a metric, let's say, to make it so and we keep only the important traces and drop the info traces, for example. Like if there is a 10 million spike, if all the 10 million spike are, let's say, at error trace, and that's where we might run into some problems. But if most of them are info, then it gives us a chance to sample those data and then drop rest of those traces. Yeah.
All right, one more round of applause for Bharathi, please.